Hi, and welcome back to DATQVAULT video lectures. This is lecture 1.3 on advanced nomenclature and will be the last lecture on nomenclature of organic molecules. So when we're talking about advanced nomenclature, we're actually going to go through a lot of the different functional groups found on molecules that could be on the DAT. Here I have a chart of a lot of the different functional groups that we're going to go over and learn how to name in this lecture that you will see on the DAT exam. These functional groups include alcohols, amines, ketones, aldehydes, ethers, esters, carboxylic acids, amides, and nitriles. You should definitely try to memorize this chart before you take the DAT so that you know what the general structure of each of these functional groups look like and how to name them based on the prefixes and suffixes shown here in the chart. Alright, so the first functional group that we're going to take a look at are alcohols, which have the general structure right here, where R is any kind of alkyl group. So when naming alcohols, it's kind of the same method as when naming any straight chain alkane. First we're going to find the longest chain. The longest chain in this case is a 6-carbon chain, which is a hexane, and the alcohols are at the 2 and the 4 position. If we remember from the chart, alcohols have the suffix -al, so we're going to name this one 2,4-hexane diol. There's another way you can name this molecule by taking the 2 and 4 and actually putting it before the diol. So it can also be named hexane 2,4-diol. Alright, now let's move on to amines. Amines have the general structure here where R can be either a hydrogen or an alkyl group. If there's one alkyl group on the amine, it's a primary amine. If there's two alkyl groups, it's a secondary amine. And if there's all alkyl groups off the nitrogen, then it's a tertiary amine. Amines are named in pretty much the same way as alcohols, except the suffix is amine, which is actually really easy to remember. So we're going to start by, again, naming our longest carbon chain. So the amine is at the lowest number on the carbon. So this one is at the 2 carbon. So we're going to call this 2-pentanamine. Again, we can take the 2 and put it before the amine. So we can name it pentane 2-amine. Alright, so the next functional group we're going to look at is a ketone. Ketones have this general structure here where the R groups are both alkyl groups, and ketones have the suffix -one. Alright, taking a look at this example of a ketone, we're going to start by naming again the longest hydrocarbon chain, and we're going to want the ketone or the carbonyl bearing the oxygen to be at the lowest number because they have priority over the alkyl substituents. So here we have a methyl group at the 3 position. So we're going to name this 3-methyl 2-butanone. So we can do, again, a similar thing where we can take the 2 and put it before the -one. So this can also be named 3-methyl butane 2-one. Alright, now let's take a look at aldehydes. Aldehydes are very similar to ketones, except instead of having 2 alkyl groups, we actually have a hydrogen group in place of one of the alkyl substituents. Aldehydes have the suffix -al. And so let's take a look at this molecule as an example. Again, we want the carbonyl to be at the lowest number on the longest carbon chain. So we're going to name number it this direction. We have 2 methyl groups off of the number 2 carbon. So it's going to be 2,2-dimethyl propanol. Since the aldehyde is at the 1 position on the carbon, there's actually no need to number the aldehyde. Alright, so the next functional group we're going to look at are ethers. Ethers have an oxygen between two alkyl groups like this. There's a couple different ways that you can actually name ethers. Ethers can either be named with the suffix ether, or they can be named as an oxo substituent. I'll show you how to name them both ways. So in this case we have two ethyl groups on this ether, so we can name it diethyl ether, or we can take this ethyl group that's attached to the oxygen and we can name it ethoxy. This is where the oxy comes from. And then this substituent right here is just an ethane. So this could be ethoxy ethane. So let's take and put another carbon off of this carbon right here. So we can name this one ethyl propyl ether, since we now have a propyl group over on this side, or we can name this ethoxypropane. Alright, let's move on to ester substituents. Esters have this general form here, where R is an alkyl group. Esters end in the suffix -08. So we're going to use this ester here as an example. So there are a couple rules that you have to follow when naming esters. First, we're going to break the ester up into two sections. This carbon chain here off of the carbonyl oxygen, and this carbon chain here off of this oxygen. So first we're going to take this carbon chain off the lone oxygen on this side, and we're going to name it ethyl, since it has two carbons. Then we're going to take this carbon chain here, which is a butane chain, and then we're going to add the O8 to the end of this carbon chain. This is going to be called ethyl butanoate. So the O8 part refers to this part of the carbon chain off of the carbonyl. Again, if we were to add another carbon to it, it would be propyl butanoate. If we were to add a carbon to this side, it would be ethyl pentanoate. Alright, let's move on to carboxylic acids. Carboxylic acids have the general structure here, where R is an alkyl group, and instead of like an ester having an R group here off this oxygen, we're just going to have a hydrogen. It's called a carboxylic acid because this hydrogen here is extremely acidic. Carboxylic acids end in oic acid, and we're going to use this substituted benzene molecule as an example. Carboxylic acids again have priority over any alkyl group, so we're going to give it the number 1 position on this benzene ring, and the methyl group is going to be at the 2 position. So this molecule is going to be named 2-methyl benzoic acid. The benz referring to the benzene ring right here. Alright, now let's take a look at amides. Amides are actually really similar to amines. Instead of ending in amine, they end in amide. Amides have the general structure here, where the nitrogen is connected to a carbonyl group, and these R's on the nitrogen can be either alkyls or hydrogens, but this R group here must be some alkyl group. Let's look at this amide as an example. This amide right here has a 5-carbon chain, so it's going to be simply named pentanamide. Alright, let's take a look at this example. So just like the N substituted amines, we're going to do this N substituted amide. So since there's 2 methyl groups on this amine, it's just going to be NN dimethyl pentanamide. The N's referring to the methyl groups are attached to the nitrogen on the amide. Alright, let's take a look at our final functional group, and those are going to be nitriles. Nitriles have this form right here, where a carbon is triple bonded to a nitrogen. The R group in this case is going to be any alkyl group again. Nitriles can also take this form, where instead of drawing out the triple bond, the nitrogen is just drawn out right next to the carbon. Alright, in nitriles, we use the nitrile carbon as one of the carbons in the longest chain. So here we have a 3-carbon chain, which is a propane. So this is, and nitriles end in the suffix nitrile. So this is going to be named propionitrile. Alright, so now that we've gone through all the major functional groups, we're going to look at molecules that might have more than one functional group on them at one time. If this happens to be the case, we need to make one of the functional groups a substituent, and the other functional group needs to be the main name of the molecule. We'll look at an example to clarify this concept. So our example right here is a disubstituted benzene molecule. If we notice, this benzene molecule has a carboxylic acid on it, and it has an amine on it. So to name this molecule, we have to figure out which one of these substituents has priority over the other one. So which one is going to get the main group name, and which one is going to get the substituent name. Remember, the main group name goes at the end of the name of the molecule, and the substituent name goes at the beginning of the name of the molecule. So if we notice, carboxylic acids up here have the highest priority, and then amines are down here with one of the lowest priorities. So the amine is going to get our substituent name because it has the lowest priority, and the main group name is going to be the carboxylic acid. So it's going to end in oic acid. So since the carboxylic acid, again, has the highest priority, we're going to give it the number 1 position when numbering around the benzene ring. So this is going to be 4-amino from the substituent name right here, and then again it's a benzoic acid. Benzoic acid coming from the main group name. Alright, so let's do a sample question that you might see on the DAT. So they want to know the IUPAC name of this molecule right here. So I'll give you guys about a minute to figure out this problem. So why don't you pause the video, try to solve it, and then we're going to solve it together. Alright, so like on the real DAT, you're not going to be able to actually draw on the problem itself because it's all computerized, so you're going to be given some kind of a laminate dry erase board, which we're going to use over here on the right hand side of the screen. So the quickest way to solve this problem is to actually draw it out, since we don't really know what the molecule looks like drawn out. So in this molecule, we have an OH in parentheses here, which means it's actually attached to the second carbon on the carbon chain. Over here, a CN means we have some sort of a nitrile, and we have another methylene group right here. So this is what the molecule actually looks like. So we're going to start numbering the molecule. If we remember from the table on the previous slide, nitriles have priority over alcohol groups, so it's going to get the number 1 on the longest carbon chain. Remember, we actually number the carbon of the nitrile, so this is going to be some kind of a butane chain. If we actually look at all of our answers, we don't even see a butane in there except for answer number B. So just based on that, we can actually select that one as our answer. But let's go through and try to name the rest of the molecule anyways to make sure that we have it correct. Since the OH is going to be our substituent, we're going to name it hydroxy, and it's at the 3 position. This nitrile over here, since it is the main group, is going to be named again just nitrile. So this is going to be 3-hydroxy butane nitrile. Alright, which again matches our answer B. So we're going to circle that one and quickly move on to the next question. So this completes lecture 1.3 on advanced nomenclature. Hope you guys learned a little bit about naming more complicated functional groups and difunctionalized molecules, which you will see on the DAT exam. So I suggest now that you actually go through and do a bunch of sample problems on nomenclature to solidify the ideas you've learned in the last 3 lectures. And I hope to see you guys back for another DATQVAULT video lecture.